Good morning, students. In the last lecture, we derived a relation for the kinetic energy of a rolling body when it is placed on a horizontal surface. In this lecture, we are going to determine or derive a relation for a velocity and the acceleration of the body when it is placed at the top of the inclined surface with an angle theta as shown in this figure. For that, we need to consider the kinetic energy of the rolling body. In this case, consider this is a ring which is placed at the top of the inclined surface. The distance from this surface to the bottom is equal to h, and the height of this inclined surface is equal to h. Now, when this ring rolls on this inclined surface, it performs rolling motion, and we know rolling motion is nothing but the combination of translation motion as well as the rotational motion. So we can derive a relation for the velocity and the acceleration of this ring when it is rolling down the inclined surface. Now how we can calculate this velocity? We can calculate by using the kinematical equation. Okay, now for that, consider the condition when this ring is at the top of the inclined surface. When it is at the top of the inclined surface and when it is start rolling, what is the rolling kinetic energy of the body? Consider that this ring having mass m and the radius of the ring is equal to r. Then what is the rolling kinetic energy of the body when it start rolling? It is equal to 1 by 2 m v square 1 plus k square divided by r square. Now when this ring is at the top point, the kinetic energy of this ring is equal to 0 because it is at the rest. But when it is rolled down this inclined surface, its velocity goes on increasing, and due to which at the final point at the bottom, the maximum velocity attained by this ring. Now we can say that when this body or ring is rolling down the inclined surface, the kinetic energy of the ring increases. But what about the potential energy of this ring? The potential energy of this ring in this initial condition is maximum because it is placed at a distance h from this horizontal surface. As it rolls down the inclined surface, the height decreases and the potential energy also decreases. Therefore, we can say that while rolling of this ring on the inclined surface, kinetic energy increases but the potential energy decreases. Now, what is the kinetic energy of the rolling body when it reaches this bottom point? It is equal to 1 half mv square 1 plus k square by r square, and this kinetic energy is equal to the potential energy at the initial point. Therefore, we can say that in this case 1 half mv square 1 plus k square upon r square is equal to mgh. Now therefore we can write here, what is this? This is equal to the potential energy in the case, that is equal to mass gravity multiplied by h. Therefore this m and n get cancelled. This v square is equal to, what happened about v square? This is twice gh divided by 1 plus k square upon r square. Therefore we can write this v velocity is equal to, it is equal to under root twice gh divided by 1 plus k square upon r square. So what is this v? This v is the velocity of this ring when this ring is rolled. rolling after the inclined surface and reach this point, the velocity at this point is v is equal to under root twice gh 1 plus k square upon r square. Now we are going to derive relation for the acceleration of the body. What is the acceleration? This acceleration is responsible for the increasing of this speed of the ring when it is traveling from this rolling inclined surface. Now, how we can calculate? We can calculate by using a simple kinematical equation. What is this kinematical equation? This kinematical equation says v square is equal to u square plus twice as. What is v? V is the final velocity. U, it is called as the initial velocity. A is the acceleration, and this s is the linear distance covered by this object. What perform linear distance? What cover linear distance? The center of mass of this ring perform linear motion. Now, as we see, the initial velocity of this ring is equal to 0 because at the top position it is considered that the ring is the stationary. Therefore, we can say that in this case we can keep the value of u is equal to 0. Therefore, we can write here it is v square is equal to twice as. Now we have to calculate the relation for a. Therefore, we can write here it is v square divided by twice s. Okay. Here we can write what is v square? V square is nothing but twice gh divided by 1 plus k square r square, and we can write here it is 1 by 2s. This 2 and 2 get cancelled. Now from this diagram we can simply derive a relation. What is the sin theta is equal to? What is sin theta is equal to? Sin theta is nothing but the at opposite side divided by hypotenuse. What is the opposite side? This opposite side is equal to h, and what is the hypotenuse is equal to s. Therefore, we can write here h is equal to s sin theta. Here we can write gh upon 1 plus k square upon r square into 1 upon s. We can write here 1 by s. What is 1 by s is equal to? From this relation we can derive 1 by s is equal to sin theta divided by h. So here we can write it is sin theta divided by h. This h and h get cancelled. We can write here as it is g sin theta divided by 1 plus k square upon r square. What is this? This is the equation for the acceleration of a body when it is rolling down the inclined surface having angle theta. As we see from this equation, on which factor this acceleration is dependent upon? This acceleration is dependent upon the inclination theta. If the theta increases, of course the acceleration of the body also increases. Now it is also dependent upon the factor 1 plus k square upon r square. If this factor increases, the acceleration decreases. Therefore, from this equation, if we consider a special case of ring, for ring, radius of gyration is equal to the radius of that ring. We can say that this k is equal to r. For what? For the ring. And therefore, if we have to calculate the acceleration of the ring when it is rolling down the inclined surface, so we can write here A is equal to, it is g sin theta divided by 1 plus 1, which is nothing but equal to g sin theta divided by 2. So, what is the acceleration of the ring? The acceleration of the ring is equal to g sin theta divided by 2. In this lecture, we discuss about the equation of velocity and the acceleration of a body when it is rolling down the inclined surface. In the next lecture, we are going to discuss about the moment of inertia of the different bodies, about the different axes by using perpendicular and parallel axis theorem. Here we are going to stop now. Thank you. Have a nice day. Goodbye.